All right, I spent some time designing a small transmitter circuit, and so here it is. So on the left, R5 and R6 establish a bias network on Q2, which is a VHF transistor. At the top, C6, L1A, L1B, those form a free-running oscillator, which is coupled to the emitter via C8. So the input is really on the emitter. It's an amplifier. This is just an amplifier. So as soon as you plug it in, and that's 9 volts on the top rail, what happens is energy is sent back and forth between C5, L1A, and L1B. So that's an inductor capacitor, a resonant circuit. So energy is sloshing back and forth, back and forth. It's a tank circuit. And, and then of course that's being amplified on the emitter. So that goes to that's the output of the collector, which should go on the air. Now, this is what I've completed so far. The other part of the circuit, is not hooked up yet and needs to be tested. But basically, that's a microphone with another amplifier, and that feeds the oscillator circuit right here. Although it's not in this case, it's broken. But normally that would modulate it, and you would get your music on the radio. So, anyways, that right there, that transistor. Actually, the transistor I got from eBay, these VHF transistors, something like, Anyway, so the circuit I put together is right here. That capacitor in the middle, right here, is not used. It's not hooked up. It's got a problem in it, so it's got to go. But that transistor is in the back, and there is, in place of that capacitor on the front, there is this small one, on the back. Which is about 6 picofarads, which is similar to the value that's in that schematic. So that was the schematic I just showed you. This is the transistor circuit. This right here is a spectrum analyzer. This thing called the Tiny SA, and as you see in the middle, there's nothing. It's not seeing anything. This right here is my oscilloscope. It's looking at the oscillator circuit. There you go. There's nothing on the oscilloscope. Now, as soon as I plug it in, there's the plug. As soon as I plug it in, you are going to see it transmitting. Boom. And you have a transmitter. So you see 3 nodes there. Actually, here, watch. I'm plugging it in again. It's plugged in right now. So 1, 2, 3, those 3 spikes that you see, the big one is the primary frequency, which is around 100 and, you can see it here, it's 117 megahertz. And those other spikes, those are harmonics. So you don't really want those. So you don't want those, actually. So it needs to be cleaned up, but it is working. So, and here's what the oscilloscope is showing, So look, I pull it off. There's no oscillations. I plug it in, and as on the scope you can see. So see between those 2 spikes right there, that is 117 megahertz. So that's pretty cool. So by varying the values of anyways, here's what I'm showing you. So that's an inductor I made, which is just the coil of wire, and and that's coupled to the oscilloscope. And so these 2 resistors, that's the bias network. This one right here, right there, that's the emitter. And this capacitor right there, that's the one I had mentioned before, which couples the collector to the capacitor. So as soon as you plug it in, 9 volts gets split to about 1.15 volts, which feeds that transistor. And energy starts sloshing back and forth in the resonant circuit, and that's exactly what happened. It's like a tank of water, where water is sloshing back and forth, But of course, there's resistive losses, so you need to add a little water every half a day or whatever, So there's resistive losses in the wires. So, anyways, so that's it. So it is oscillating, and it is showing up on my little spectrum analyzer, And so that is 22 minus 22 dBm down. So that actually, that signal that you see there is more powerful than, you see that other spike right there? Well, those are the local radio stations in Connecticut. So I'm actually broadcasting over them. So that's kind of cool. I mean, obviously it's not going that far, because there really is no antenna hooked up to this thing. But so my goal is I'm gonna set up a little microphone on this thing, a little small amplifier in the microphone, couple it to this, and make a small AM transmitter and just see if it works. And it should be broadcasting not that far, 25, 50 feet or so. But it's kind of neat. Of course, there are some issues with this, with the oscillator, and that it does not take much to. So it's running now, but it doesn't take much to kill it. Literally, like as soon as you touch the coil, it gets killed. But there's some issues to figure out, but pretty cool.